In lesson 4, we extend our work with proportional relationships by looking at proportional graphs. And we started by taking a look at a bunch of proportional tables that we knew had a constant unit rate. And we also talked about this new term, which is constant of proportionality. Constant of proportionality is simply the constant unit rate. It's just another 7th grade way of saying constant unit rate. So when you hear constant of proportionality, think constant unit rate. Sometimes you'll see us abbreviate that as the COP. So we took a look at these tables that had proportional relationships, and then we looked at their matching graphs. And the things that we noticed were that proportional graphs had 2 things that had to be true. One, they had to be linear, which means that it is a straight line. Also, besides being linear, they had to go through the origin. So in these 3 examples here, if we want to know which ones are proportional, we would say that this is a proportional graph. It's linear, and it goes through that origin, which is the point 0, 0. This table is linear. You can see that it's a straight line, but it does not go through the point 0, 0. It goes through the point 0, 3, so that is not proportional. This graph is not proportional because it is not linear. It does start at the origin, but it still has to be linear. We then took a look at some points on this graph to kind of ask ourselves, what do these points mean? So different points on the graph represent different things. So this graph here you can see is comparing cups of water to cups of lemon juice. So when we look at this point here, they're telling us this is the point 10, 5. So that means my x value is 10 and my y value is 5. So my x value are the cups of water. So that means 10 cups of water is going to give us 5 cups of lemon juice. So in this lemonade recipe, you're going to need 10 cups of water combined with 5 cups of lemonade. 4 cups of water with 2 cups of lemonade. So looking at this graph as well, now that we're connecting these points, they're asking if this is a proportional relationship. So you can see as you look down here that it does cross through the origin and it is linear. That point 0, 0 becomes an important point to us. So they often were going to ask us what that point means. And it's just similar to what we did up top. So that means if I have 0 cups of water, I'm also going to be using 0 cups of lemon juice. Every graph that we make can be made into a table. So they took those points from the graph. This is our x, this is our y. Dependent variable, independent variable. You can see the points. If we're looking for that unit rate or that constant of proportionality, we would be taking the cups of lemon juice and dividing by the water. So in this case, our y divided by x. So 1 divided by 2. You could leave it as 1/2 if you prefer 0.5. That would be fine as well. So this 0.5 is our unit rate, now known as our constant of proportionality. That sums up the lesson. So then that lesson brought us to this exit ticket, which is exit ticket number 4. And now we're looking at the money Pedro is earning doing yard work in his neighborhood compared to the hours that he spends doing this work. So the first thing they want to know is it proportional? So you can kind of check to see if it is in fact linear. So you can check that oftentimes by using a straight edge. It doesn't always have to be a ruler. But you can see in this case, it is linear, so it is proportional. And it also goes through the origin. Which is that point 0, 0. In order to be proportional, it has to be both of those things. 1, it has to be linear. 2, it also has to go through the origin. So this asks the point 0, 0. Pedro puts that on his graph, and they want to know what it means. So 0 for my first coordinate, my x coordinate, represents the time in hours. So 0 hours worked is going to be equal to my y coordinate, which is also 0, and that's $0 earned. It then wants to know how much money Pedro will earn if he works for 1 hour. So this is our unit rate. This is our constant of proportionality. It is the point where my x value is 1. So in order to do that, you're going to have to find a perfect point. And that is kind of tough to find. So when we find that perfect point, when I go here, it looks like this is a 5 and this is 40. So when I see that 0.540, I'm going to do my work over here. My x value is 5, my y value is 40. This is my x, my y. My dependent variable is the y. My independent variable is the x. So we're going to be doing y divided by x, which is 40 divided by 5, which gives us 8. So that is the 0.18, which tells me that if he only works 1 hour, he will earn he will earn $8 per hour. That's lesson 4, proportional graphs.